Media page I mentioned. All right, first of all, welcome to the wonderful world of regular expressions. The big reveal finally came in. All right. And for those of you who are wondering, the background image I'm using is the GNU+, that David Ravoy did at LibrePlanet last year, which is awesome, and I've been using all over the place. So, and he's speaking again this year. I don't know if he already spoke. I haven't been able to watch the calendar the schedule that closely yet. All right. Almost caught up with where I am.
Do you want to skip ahead a few? You can always select the number from the drop down.
Yeah, that's true. Well, we're coming up to the one I'm on, so
all right.
Yeah. would have made it easier. Anyway, so the introduction. So regular expressions are sequences of characters that define a matching pattern using a specialized language. So you really can, to me, as a non-linguist, think of them as a mini language unto themselves. They define patterns that describe sets of strings. We're doing string matching, string being a line of characters, right? We're looking for characters in a row, letters, numbers, those types of things. Can also include punctuation, some other and some other stuff, but we're going to concentrate on basically the things that you see on your keyboard. They're used in many common Unix tools. A lot of the free software stuff that we have, a lot of the free software tools we have, the GNU tools, did a lot to extend and improve regular expressions back in the early days. So a lot of the capabilities we have with them today and making it easier for us humans is actually thanks to the free software or the GNU project itself, right? So we're going to use that. So tools like grep and sed. They can also be used in many programming languages, Perl, PHP, Python. There's also database query languages. Most that I've worked with, actually possibly all that I've worked with, also support regular expressions of some sort. When the slide catches up, you'll notice I put regex, R-E-G-E-X. That's just a shorthand for regular expressions. I will possibly say both during the presentation. You'll see both in the slides, meaning the same thing. Now, as I say, the GNU project went through an extended regular expressions, and I don't know that they were the exclusive, but that's the place where I experienced it, was with the GNU tools. And so we call those extended regular expressions. Those are commonly available today in most of the tools that we have. And they're easier to use for us humans than basic regular expressions. Both of them are capable of matching the same stuff to a large extent. There might be a couple differences. But from a syntax perspective, from a typing perspective, the extended regular expressions are easier to use because we need less escape sequences. We need to do less things to make sure that they get interpreted as we want them to be. You can see the regex man page, which is man7 regex, to see more information about that and do some of your own research. For when I first created this lab, actually, I went back and looked, and regular expressions were created in 1950s. So we've had them for a while before the GNU project existed. It was a mathematical construct back then, but they were popularized in computing by the different Unix derivatives and clones and by the GNU tools. Yeah, that's that. So let's see if we can go to slide 8. I don't know what is taking so long. All right. And I usually have slides up ahead of time where I can grab them. There we go. All right. So things that are not regular expressions. Regular expressions are not globs. For those of you familiar with globbing on the command line, they use similar characters, but for pattern matching, but they do them in different ways. Globs are evaluated by the shell before the command is run. So generally, right? So you're doing file system matching, file matching. Regular expressions are evaluated by the command line or by the command itself. Generally, as I say, there are commands that understand globs, and there are ways to use regular expressions within the shell. But generally, that's what we're looking at. in general, you want to use quotes to protect regular expressions from accidental globification. We'll get to that. We're going to start off without quotes, and then we'll start introducing quotes as it becomes more apparent why we need them. Globbing, like I say, is mostly for file name matching, and regular expressions is pretty well everything else, right? As I said, there's a general rules. It's not a written law somewhere. Regular expressions are not explicitly limited to one line, so they can cover multi-lines, but most of the tools where we use them are doing single line matching. By default, there's ways of getting them to do multi-line matching. But in the GNU tools, for the most part, we see a new line as an end of trying to match. Which is not how they work internally, but that's how they work for matching. They do not recurse, so you can't use them infinite underneath each other. You can capture and reuse, but that's not recursion there. And regular expressions are essentially state machines for those of us that are familiar with those. So, and the slides will be available publicly. So I see the question about that. Normally I have them on my site ahead of time. I was slow this time, so I didn't quite get them up there. But they will be up on my site, and I will also make sure that they're available to LibrePlanet so they can disperse however they want to do that and make them available. All right. Okay, so this is a workshop. We're going to do some labs. And so for that, we need to do a lab setup. And to that end, we can run these commands.
I'm sorry, but I cannot see the image on the slide.
You cannot see the slide?
No, I can't see the image itself. I think it's the zoomed broken image icon.
Okay.
Just displaying.
So you can, there's a button in the bottom right-hand corner where you can make the slides full screen if you want. You might want to try clicking on that.
It doesn't help.
Yeah, I've just tried that.
Okay.
Make it full screen.
All right, let me see.
If the font is too small, I didn't quite catch the original issue, but yeah, it shows up for me. It could be a browser-dependent thing.
Let me see. Yeah. Thought there was a way to share a file here. All right. Give me a second here. All right, so there's some commands we can run for a setup. For those of you who can see that, get your lab created and let's get this. You know what? Actually, what I'm going to do is, okay. We're going to get to in a little bit. We're going to get to a lab, and I can go through and make the slides available then. Or who is that? And Andre, you were asking about this. Yeah, I can.
No, I was reporting the issue with the slides.
Okay.
Yes, me too.
So okay. So what I'll do is during the let's see. Let me skip ahead a little bit. Be good if you could see what we're doing here. Okay, I've got the slides over in the right place. Now I just got to, or in the right machine.
Oh, okay. I've connected with another browser, the Firefox, and it works. So I will just
Okay.
stick to the Firefox. Sorry,
All right,
sorry
we'll go
for
there.
your time.
All right. Cool. Okay, so you can see the lab set up. And this is actually set up so you can, if you can, well, that would, if I'd have made it available earlier, let me do this myself. I changed the file format I used, and it didn't occur to me to test that I can get this. What is going on? The point was to make it to where you can copy and paste those commands, and all right, something else. Okay. There we go. Okay, let's see if that comes across. Get a copy out of that. All right. So if you copy what I just posted in chat into a shell, that will go through and create a directory for the lab and CD into it, and then create a few files. There you go. And then this will go through and create a file with some particular content in it.
Yeah.
Okay. All right. Cool.
We're getting a little bit of background noise, so if you could all try to be muted when you're not speaking, that would be great. Thank you.
Yeah, there we go. Okay. All right. Oh, let me, one of the things, I don't know why the slides are taking so long to pop up for here. So as I said, during the break, I'll work on getting the slides up on my site, and so that everybody can follow along on their own. Maybe go ahead and start in. So I've got some examples here for regular expressions. You won't be able to see them until it comes up on the page. So I just showed an example with sed to delete trailing white space off of lines. For searching dotted quad addresses, somewhat sloppily, so it's not exactly searching things. I'm using a regular expression. MAC address, we can look at those later on. Lab conventions, we're going to come up on, I'm going to move page, so we need to get to 13. Let me move the slides forward to the page that y'all need to see. And let's skip the other two. Okay, there we go. Well, we're getting there. All right. So some conventions I have are just how I'm showing the information. If you're familiar with the command line, you're familiar with general Linux and Unix type of stuff, you should be fine with those. And notice that I accidentally got some single character escape stuff in the slide. Hey. All right. Oops. I want to go to 14. All right. Just reading it wrong. All right. So the first tool I'm going to use is grep. Mentioned it a couple times. So grep stands for Global Regular Expression Print. Go down in the resources at the end. I've got a couple links to a history of grep. It's actually really, really cool. I enjoyed reading those. If you want to know more about grep and where it came from, go look for those. The basics is it's looking for patterns of lines in text. So, all right. So the example I give here is how to search for a plain text string, and I echo out some text. I pipe it and grep for a substring within that text, so a part of that text, and then I get the line back. In this case, I'm echoing out LibrePlanet 2021, and I'm grepping for Libre with the same capitalization. And the reason being that grep is case sensitive by default, so it's looking for the exact string, uppercase, lowercase, that we use. My next example, I use the -i option for grep to say look for case insensitive searches, and I look for Libre in all caps, all 5 letters in caps. But once again, I get the results back because now that I'm looking for case insensitive, it doesn't matter what case I gave it or what case the text was that I was searching. It does, it basically does a too lower on both. I don't know what it does internally, but that's essentially what it does on both, and looks for it that way. And then the final example I have there, just because it can be useful for people, especially if you're trying to create examples like I'm doing. Mark, they're not coming up. They're not coming up for me either. So I'm trying to get there. So I did testing on my own instance before, and it was working fine. So I don't know if I changed something after my last test or what. So I'll work, like I said, I'll work on getting the slides up on my site so everybody can go download them during the break. So I got a few weird things on how I do that. So anyway, so the final example I have on the screen that none of us can see is I'm using grep with the -i again for case insensitive, but I'm using the -o option as well. I can combine those together in GNU style, and so I do a grep -io. And what O says is just show us the parts that match. And so if you're trying to go through and demonstrate for people what's happening with grep, this can be useful. It's also useful if you were just looking for certain things when we get into regular expressions. But in this case, I did repeated the case insensitive search from the second example, but I only got back the Libre, capital L, lowercase ibre, from the original string, which someday, somehow, everybody will be able to see in its glorious plain text. All right. Okay, let's go ahead, and those are basics of greps. Again, most of us shouldn't be familiar with that coming in. The -o operator isn't that common, but it's still it should be self-explanatory. All right, so for slide 15, let me see. Let me try one other thing and just see if this works better. Oh, come on.
So sometimes the slides don't show up if there's a SVG on it. I'm not sure if you use that.
I don't think I used an SVG. The background I think is PNG.
Mm-hmm.
Let me see. Well, let me just try rebuilding them real quick without that in there. Oh, it's a PNG. Okay. Okay. All right. Ooh. I still have my St. Patrick's theme up. That'll work. Okay. That's loading up. So while it's loading up, I'll go ahead and give us some content. So this slide that isn't showing, I'm talking about the dot operator. The dot operator is a period, right? We also call it dot because it's shorter and easier to say. But it's the same thing. It's a mimic and similar to wildcard in poker. So it represents any single character right at that exact point where it is, right? And it matches exactly one character. The example I give is I say find any files from the samples that we had that have 7 characters in the name, and basically I grep for ... So I grep for 7 in a row of any character, so that will match anything. And notice it doesn't, in the example you can't see, it doesn't have to be the same. Oh, there we go. I'm sorry, I forgot to hit a button. It doesn't have to be the same character, right? So I'm not looking for 7 Y's in a row. It can be A, B, C, D, E, F, G, right? So any 7 characters in a row, including punctuation and anything like that. Now also, it must be exactly one character. The next example I give is I grep for HTM dot. And if you look at the files in the file system, you'll notice that it matches those that end in HTML, but not those that end in HTM without the L, because it needs to be at least you can say a single character. All right. And then the next slide. It is not we can call it a period, but it's not a period in the match. It is a special character, means any character. So the example I give there is file HTML without a dot in it. So we got file dot HTML or file period HTML, however you want to say it. Let's see. Woo. What slide am I on? 16. Look, I did actually create slides that weren't blank. All right. Let me back up a slide, actually. So this is the dot operator. First of all, I can see them. Can everybody else see them?
Yes, I can see them.
Woo! All right.
Yes.
Good. It wasn't a figment of my imagination. I actually did write the presentation. All right. So the example I gave there, as I mentioned, was 7 characters. Then with the dot at the end, it needs to be HTML. And then here's the example I was talking about, where searching for .htm also picked up file HTML without the period in it, because it's matching any character. And then we'll cover later on how to get it to be match a period instead of matching a dot. And then here's an example where I'm doing error-prone search for both Maya and Maya, 2 different spellings of the same name. But notice that I also got Mexer. I've never met any Mexers, but if I had, that regular expression would match that as well. So, all right, we're getting to the exercises. So this one will 5 minutes to begin with this. So in that directory that we had, that I had you create in the lab, and I'll go back to the lab slides in a second. Although, as I say, the information was posted into the chat. Actually, I'm not going to go back to. Well, yeah, I can. I'll copy and then we'll do that. So I'll give you 5 minutes to work on these labs, And if you do have any questions, Cyber, I'll be posting. Look up in the chat for the. I'll say this in a second. So if you have any questions, go ahead and put them in the chat, and we'll try to be quiet so everybody can concentrate instead of listening to me yammer while you're trying to work. So Cyber, up in the chat, there are 2 posts I made about setting up the lab, and then I'm going to copy in these exercises now as well. All right, I got the slides on my site, but I'm doing something wrong, so they're not working yet. I'll keep working on that. All right, chat. All right. Okay. Oh, actually, I don't need to do it that way. Okay, I'm going to paste in the examples from the dot. There we go. I've been doing this presentation with a basically with a live website for a while, and because of Big Blue Button, it's easier to do it with PDFs. And I forgot that in this case it's interactive, and to make sure it'd be easy for everybody else to get to it. So sorry for being not prepared. You know, it takes multiple things to break, but it did. All right. Anyway, so here we've got those are the examples that came from the last couple slides. As I say, I'm working on getting them available for everybody to go grab as well. So for the exercise, okay, good. I turned sound on. All right, use ls to list all files in the lab directory, and then use grep to search for output for file names that are at least 5 characters long. That's essentially the first example I gave, where we're looking for 5 dots instead of 7 dots. The number 2, we're using grep to search for output for file names that have an E in them. So that would just be an ls pipe to grep E. We're not even using a regular expression right there. We're just looking for a single character. And then the third is use ls to list all files in the lab. Use grep to search output for file names that have an E in them, followed by at least 2 characters. So, oops, I can't go back to my previous command in chat. So this one, we're just looking for an E followed by ... All right. And let me... I will go ahead and paste the full output from that last example there. All right. Let's move forward. I can remember how. All right. So I can look for a dot just anywhere in the text. I can look for this thing. I can look for an E anywhere in the text. But sometimes we know where it will be. We can anchor that to the beginning or the end of the line. There's ways of anchoring it in between. We're not going to get into that too much, but the beginning and end of line anchors are really important, and they'll demonstrate the concept. And from there, you can experiment more. So the beginning of string anchor is a caret. It is also known as a hat or a caret. It is on an English keyboard anyways, generally Shift 6. I had a little look, yeah. So it anchors the beginning of the line. There's another anchor we'll get to. In this example I'm giving now, we can search for password lines with bin in them. And then we use head to restrict the output to 5 lines because there's a lot of entries in there. I don't want 6 slides of text. I just need to show you what we're doing. So grep bin from Etsy password, and you can see that I've got a bunch of lines that have there. So anything that's got a shell or some kind of login will have bin in it. So we got those as an example. But we can also search for lines that begin with bin by by anchoring to the beginning of the string. So bin is an account. It's a normal account on a Unix-like operating system. And so when I do grep caret bin, I say look at the beginning of the string for bin. Then when I come back, I only get the one line for the bin account. If I had a bin and go account, I'm certain there's a bin and go store somewhere in this country. If I had a bin and go, actually, I guess that would be more UK. So, but if I had a bin and go account as well, then that would also show up, right? Anything that starts with bin on it. Okay. And then I'm going to look for 2-character account names. Now, in this case, I'm using a field delimiter to help me. So I'm, again, grepping, using the caret to look at the beginning of the string, so the beginning of the line inside the file, ... for any character followed by another character, and then a semicolon. So the password file is basically a plain text database of colon-delimited fields, right? So if we look at this result from that, we have LP colon. So the first field, LP, is the name of the account. The colon is to say we're going to the next field. The X is the password. So if you use X, you can log into my printer. No, X says to go look at the shadow file for the password. It has been the case for many, many years. I just read a book about why we need encrypted passwords. I just read the Cuckoo's Egg over the last week. And then colon to end that password field and then a 7, which is the user ID, and a colon, a 7, and the group ID, and so forth. So there's different fields. They're all separated by colons in the password file and have been for decades. So when I'm looking for text within the first field, I can then use my colon to anchor that field. So I have a caret to anchor the beginning of the line, any 2 characters, and then the colon to anchor. So I'm looking for any user account name with 2 characters. All right. All right. Then we have the opposite side of things, the end of string character anchor, and that is a $, or EOS. If you'll see it in some places shortened. And that means match the end of the line. So instead of the left side, we're matching the right side. Well, in English, their languages go the different direction. And I have truly never thought about whether they go the other way. I would presume they do. I suppose I will have to learn just to know. So search password for accounts that have bash as the login shell. So in this case, we're grepping for /bash. And then the $ to say the end of the line. So I'm looking for a line that ends in bash, in /bash, and the last field in the password file is what your login shell is, right? So we can see that I got a couple back here that have etc password, or in etc password that have bash as a thing. I'm betting when I ran that example, I put it in the head, so there's probably an error on what I copied there. And then I can search password for accounts that have 4-character default command. So again, I'm using an anchor and or field delimiter, not an anchor. The anchor is the $ to anchor to the end of the line, but I'm using the / as a field delimiter to say look for something. So the last piece of it, which is the file name, not including the directories, would be 4 characters long, and I can see that. So I'm taking advantage of the anchor to put it to one side of the line or another, but I'm also taking advantage of the natural delimiters I have within the text that I'm searching within the actual data. And this comes back to actually those questions about the this character or the domain specific languages and so forth. Is I'm building a mini domain specific language to the actual data that I'm looking at. I don't know academically if any of that matches because it's not my field. I can't speak coherently about it as you're seeing, but maybe that's a way of thinking about it. All right, so we'll do a couple of minutes to play with anchors. Now, the first one, I'll give a little hint. You're combining them to figure out what's going on there, and then let that go. So again, I'll take 5 minutes. This time I'll remember to put the timer on. And I will, again, mute to allow everybody to think. All right, I think it's been 5 minutes. I can't math. I set my timer for 10 minutes instead of 5. Sorry about that. So let's search file for empty lines that have no content. And for that one, we're going to grep. And we just anchor together. So beginning a line with nothing, and then the end of line. So I'm looking for a line that has no content. It just has a beginning and end. Those aren't real characters. They're just matching the edges, right? So that is saying look for lines that have nothing in them at all. Now, if I want something that starts with, for exercise 2, start with a hash to comment them out, then we can anchor followed by a hash sign. And then that end in E followed by Y. So then the final example is we're looking for E dot and then the end of line. All right. Yeah, it's catching up on the chat. So this is running off my home system on a different ISP than actually what I'm doing the presentation from. I looked at the PDFs by using that background image from David Ravoy. I doubled the size of the PDF, and y'all are essentially DOSing me right now, which is fine. So, all right, let's go ahead and move on. All right, operator match 0, 1. So this is saying match. So dot says to match exactly 1. Question mark says maybe 1, right? Maybe none. But again, remember it's matching whatever comes in front of it, right? It's not matching where it is. It's matching whatever was in front of it. So if I say match a question mark, it means match an A or don't match an A. 1 or 0 A or 0 or 1 A's, right? Now, if I combine that with the dot, I say match 0, 1 of any character. Back in the example I gave early on about HTML dot, and that would only get HTML. If I do HTML dot question mark, then I would also get the HTML files as well, which is the example I give here. Actually, I'm not using a dot. I'm using the L because if I did dot question mark, I could also get HTMX. I don't know what an HTMX file is, but I would match those as well. And then also, this is the slide where I say that we want to use extended regular expressions for grep. That is a -E option. There is a tool called egrep. They have different. If you go back and look at the history, it's really interesting. They have different origins, but nowadays egrep is basically a link or a wrapper around grep-E. I recommend using grep-E instead of egrep, so that should egrep ever go away, I don't think it will, but to me it makes it easier if we all keep it the same. Also, if you want to change it somehow, to me it's easier to change the command line arguments. All right, so here I'm going to, we're talking about internationalization with different languages. I'm going to internationalize between US English and UK English for one specific word. And Canadians and others use the UK spelling as well, and I don't know that British is the right way to call it, but that's what I've got. So anyway, so I can look for color with and without a U, and you can see that I've got the result there finding that. And then I can also do a convoluted answer or question, and I'm searching for files that start with a T. So we need to anchor to the beginning, have a T, and then have any characters from 3 to 5 characters. So I can do that by putting dot question mark at the end of 3. So I need to have, well, at the end of 2, right? So there are 3 to 5 characters long to begin with. So the T is the first character, then any 2 characters, and then maybe a 4th one, and maybe a 5th one. All right. So this is a quick exercise. We're not going to take a couple minutes to do this, but list the files and search for those that start with an A and are 1 or 2 characters long, and then also list those that have an O in either the first or second spot. All right, I'll just give basically 2 minutes for this. Okay, so the first one, we want to anchor for the beginning of the line and then an A, and then 1 or 2 characters long. So the 1 is the A, and we can do a dot question mark. Say, oops, and I forgot my dash E. So let me retype this as, there we go. All right. So Felipe, so what you're seeing there is what I was talking about before, where we need to quote things. So you're getting into a position where we need that, and I guess that's fine. I haven't covered it yet. I thought I was fine without them. So we'll do that example, and we'll use the quotes to make sure that that's obvious for everybody. So I'm going to use single quotes. List files that have an O in either first. Okay, so well, for the example you're doing, I've got it up on my GNU cloud. The catching up with the conversation. I've got the file up on my GNU Cloud instance, a Nextcloud instance, the smaller version of it, and I'll make that available as I get a chance. Make it easier for everybody, but it's still 4.5 meg. The other one's 9 meg. That's still not that big. Jeez. All right. So if you're looking for something at the end, so let's say I wanted something where it had the E as the penultimate character in a file name. Let me catch up with what I'm thinking. There we go. So this would be a way of doing that, where I grep for E followed by 0, 1 character, so the penultimate or the ultimate character, I guess, in the file name, followed by the end of line anchor, the $sign. And yeah, you're right. We're using special characters now, and some of these mean something to the shell. I'm going to get to that in some slides here. But that's why we want to use quotes on regular expressions on the command line, and really anywhere we go, because not doing so gives us bad results. And I'll give an example to see what kind of results we get that. And then for exercise 2, let's do that. Go ahead and do the quotes. So we want a beginning anchor, and then 0, 1 characters with an O. Okay. All right, so I mentioned varieties early on. Most commands understand extended regular expressions. And so I suggest using those when the tool supports it, but some of them default to basic regular expressions. So you might need to tell it to use the extended regular expressions. That's what the -E is telling grep. It's saying use the extended regular expressions. Grep will default to basic regular expressions instead. egrep was specifically meant to do extended regular expressions, so you don't need the -E with it. But as I say, I recommend using grep -E instead. Practically, they're the same thing and have been for a long time. There's also Perl compatible regular expressions. And what I suggest when you're using a programming language, most programming languages support PCRE. So I suggest using either those or the native regular expression that the programming language has unto itself when you're programming. So when I do shell, I use extended regular expressions, and including when I'm shell programming, writing a shell script, and I'm using command line tools. But for most everything else, I try to use PCRE. The concepts we're covering will also work in PCRE. There's some other options in there as well, but I don't really have time to get into PCRE in addition to extended regular expressions in the time that we have, especially with all of the extra challenges we had today. All right, so let's go to the plus operator. The plus operator says match one or more of whatever came in front of it. This is an extended regular expression. It's not in the basic regular expression, so we need to use the -E at this point in order to use this. And here I'm using, for the example, I'm looking for an O followed by one or more O's. Right, so it's got to have 2 O's in a row, but can have more than 2 O's in a row. As the example shows, we get 6 O's as the output. And then the next example is look for lines that have been commented out, but start with at least 1 space. So the first character in the line is a space, and there are 1 or more spaces before you get to that comment character. So we're going to combine several things that we've been using thus far. Grep -E, the extended regular expression, and then we're going to quote now because this is getting more critical for what might be interpreted on the command line. Then we're going to start our regular expression with a beginning of line anchor, the caret, and then a space, and then a plus to say at least one of those, maybe more, and then the hash that is the end of the string that we're looking for, and then an end quote to finish it up. And then look for things that have a P followed by one or more E, and then an L. So in this case, I again using dash capital E, single quotes to avoid shell interpretation, a P, an E, a plus to say one or more E's, and then an L and the end of the thing. And you think, what is repealed? That's the wrong word. No, I peeled some vegetables the other day. My wife repealed them, right? Okay. All right. Operator star, also called splat and asterisk. I haven't heard anybody call it splat for a long time, but I still do occasionally. That is similar to the plus, and it is in basic regular expressions as well as extended regular expressions. And that basically says match 0 or more of the thing before it. So if I say E star, that means match 0 or more E's. So if I have the repealed, it'll match the E after the R, but also the 2 E's between the P and the L, and the E between the L and the D. But it'll do some more. Now, again, I'm mentioning quotes here. We'll get some more in a second when I get to the examples. So as I say, it matches 0 or more of the thing. That also includes the empty string, which is a string that doesn't exist. So I want to show some examples of different things in this. We're not just doing regular expressions. So I'm echoing a star. And in order to do that on the command line, because star would be a glob, I need to put that in single quotes to protect it. Then I'll echo out a star. Then if I grep for a star, again in single quotes, that'll show that, right? But if I echo out an A and grep for star, it won't match anything because, again, in the regular expression, the star is looking for 0 or more of the thing before it. Since there's nothing before it, the star is just a star. It's just an asterisk. It's not a special character in that example. But if I echo a star out and then grep for dot star, now it'll match because star is anything, right? 0 or more anything. Same thing works for the A. And then, of course, A star will also match the A. As I said, the dot star matches nothing as well as something. So here I've echoed out an empty string. There's nothing there. But the end line, the grep still matched it. That's why we have a blank line there. The grep matched the nothing and gave us the end line from that echo that is there in the example. Now I can search for lines that have been commented out that might start with spaces. So this is similar to what we were doing before with the plus, where I was looking for 1 or more spaces, but now I'm looking for 0 or more spaces because it's matching 0 or more of whatever came before it. So let me talk about quoting a little bit. So all regular expressions used in the command line and in shell scripts, because essentially that's a command line, should be quoted to protect them from shell interpretation. As I mentioned at the beginning of the workshop, globbing uses some of the same special characters that regular expression uses, and they use them for similar reasons, but differently. Glob says the star means match 0 or more anything, doesn't refer to something before it. It just says right here, in this place, 0 or more of something. But that also means not only does it do it differently, but the shell will grab that character and use it as a glob if it has the opportunity to do so. So we want to quote when we want to use it as regular expression to make sure that the shell doesn't try to go through and grab that and use it as a glob. So I default to single quotes when using regular expressions to the extent possible. But sometimes you do need to have some kind of interpretation. So double quotes are used for shell variables and stuff to allow those to continue working. So if you need to use shell variables or some other interpretation that is allowed to double quotes, use those. But default to single quotes to avoid accidental interpretations. So we're going to do it another exercise. List files. So let you read those. Again, I'm on mute. And again, if you have questions, go ahead and ask in the chat. All right. Since I have that example up, let me give the updated version of question number 1. Sorry about that. I'll have to go back through my old revision control to figure out what I used to mean. Here's the example. And then use a star to emulate a plus. So to emulate a plus, what we want to do is say that we have, again, one or more of something. In order to do that with a star, we basically just put the one thing and then we say 0 or more of it afterwards. So, so we want P followed by 1 or more E followed by an L. So that example, I'm grepping, I'm looking for the letter P, then the letter E to make sure I have at least one of them, and then 0 or more E, and then the L. Double slide. Okay, all right. Okay. And I'm not certain why this last example was a is an example for star. So I'll need to make notes. I need to make a couple fixes to this. All right. Okay, regex, as I mentioned, is not a glob. So here's an example coming through. One more E. So in globbing, so the grep I'm showing is similar to what we've been doing before, where we're using double E. We're using double O in this particular case. So we're saying look for beginning of a string followed by 1. So an O at the beginning of the string followed by 0 or more O's. If we do this as a glob, the LSOO glob will match file names that have 2 O's in them at the beginning. Because again, the star is afterwards. So I'm saying the glob is saying, look for O followed by an O followed by 0 or more things, whatever those things are. O star. So if I just do the grep O star without quotes on it to protect it, I get back no results. And the final example here shows why. So I'm taking ls and I'm piping it to echo. Echo will then ignore the output from ls. And echo then actually goes through and shows the command that was being run, that the command line, that the shell passed up. And what happened with this is that the grep of O star, the star was interpreted as a glob by the shell. So the grep actually turned into grep of 1 space 6 O's. And that's why it didn't match anything, because that string isn't a file name. So we didn't get a regular expression match on that. We were basically looking for a fixed string because the shell had gone through and used a glob to grab that star. By the way, for those of you that do teaching or anything, if you're ever doing this, do not teach globs and regular expression the same night. You will hurt your students. I learned the hard way. Actually, it was 2 nights in a row, or subsequent nights, I would recommend putting some things in between to give them time to absorb it all. All right, we're going to talk about sed real quick. So this can do a bunch of things. What we're going to do here is we're just going to use it to transform search for something and turn it into something else. In sed, we use an S to indicate that we're doing the search. And then our default is slashes to separate the different fields. So S / what we're looking for / what we want to replace it with, and then a trailing slash to finish off the expression. We could actually have some things after that. We'll get to that in a second. Tool is one of the, we're echoing out tool. We're looking for the OL and turning it into AD to turn tool into toad. All right. Example here. And then if we want to find it multiple times, we can use the G at the end to say global, so it'll match multiple times. We've got some examples here of how that works. And I have example or explanation of the -RE, which I recommend using. You can come back to that. And then instead of slash, we can use other characters. We can use really any other character. I recommend using the @ because it doesn't mean something special in most cases. It does for me for Perl stuff, but on the command line, it's a fairly safe one to use. Comma is a safe one to use as well, but it's in a lot of our content, so that becomes more difficult. So that slash in this search expression is just a delimiter. Whatever you use as the first character after the S becomes the delimiter that's used. So we can use an @ instead. Here's an example using an @. Notice we still have slashes in there, but now I'm looking for /etc/, and the ats are my delimiters in that search expression. Here's an example using commas, and then I think I have a page of, okay, we're going to use, I can also use alphabetical characters. Here's an example with Ys. And then I want to point out that when I use grep, it's returning just the things, the lines that matched by default, whereas sed is returning everything because it's not actually doing it. All it's doing is transforming, and everything else is passing through. So the lines that didn't change continued getting passed through the sed. Only the lines that change, and it just changed certain lines within it if any of them matched. There's ways to change that. Give the execs there. All right. Here's an example where I just run through a whole bunch of different delimiters to show that it works. I'm using punctuation, different punctuation for my examples there. All right. So let's look at this. So we're going to turn the first one or more O's, the letter O, into a ZZ, capital ZZ. So ls, pipe it into sed. And here I'm using the -n that was mentioned on the previous slide to say don't output everything. But then I need the trailing P in the expression in order to say print out the line you did find, the ones that you did change. So I'm turning sed closer to how grep works, where it's only showing me the lines that match the regular expression in the end. So one, notice that it matched the O, a single O, one or more O's, but then it turned that match into ZZ. So one character became two characters. The next one is the O. I don't know if I got all those right, but the 6O word, that got matched once because it was one or more O's, and then that entire match got converted to a ZZ, and so forth. And then turn the first two or more E's into ZZ, so similar type of thing. But here I want to have two E's, so I have an E followed by one or more E's. Right? If I wanted to turn this into a star, it would be E star, right? Where it says two E's followed by 0 or more E's. All right, the beginning of the string is a null string. So I mentioned we'd get to this. This is where we show the example. So if I look for E star, that means 0 or more E's. Well, technically, the null string is 0 or more E's. So wherever I have a null string, that will match. And it turns out the beginning of the line is a null string. So in each of these things that I found, I grepped for files that have an O in them, but then the sed went and matched the beginning of the line for each of those words and converted that empty space into a ZZ. But then if I use the G for global, so it'll match multiple times, the first example on this page only matches the first match. The second one will match all of them. So the letters between each, or the spaces between each letter is also null string. And that's why one turns into ZZO, ZZN, ZZ, being that the final ZZ did in fact find an E, and it converted to ZZ. And then we have other examples in there. I don't even know which ones those were in there. All right. So regular expressions tend to be greedy. That means they will match as much as they can. So when I search the string Frederick for an E followed by one or more characters, it will grab that E, that first E, and then the rest of the string, because those are all one or more characters, and it will replace it with whatever I said to replace. In this case, with EE. So I'm turning Frederick to free. And then give the same example again. Okay. Oh no, the first one was we're using a plus. The second one is using a star, because nothing after the E is still the same. So in this case, they match the same amount because we're using a dot. And we have more than one character after the E. All right, some more examples. All right. We can also invert our searches, and this isn't regular expression per se, but it's a useful tool for grep, where I can say match anything, show anything that doesn't match. So I'm saying grep for the letter E, and if it has the letter E in it, don't show it, and show everything else. So that's what the -v says. It says show us everything that doesn't have the thing that matches, and that includes regular expression stuff. All right, we have a longer lab. I'm going to find out how much time I have. This has gone way over because of the starts and the problems we had at the beginning. So I'm actually going to set this lab for 10 minutes instead of 20. But if you have further questions, get a hold of me. If you don't get through all this, we can come back and talk about it out of band. I'll gladly help out later on. And then if everybody finishes, please let us know, so that if everybody's done in 5 minutes, we can move on.
Hi, sorry to interrupt. We actually only have about 2 minutes left because the workshop was scheduled to end at 5:20 Eastern. But of course, feel free to communicate with people through the IRC channels and through other channels.
Okay, thanks. That's where I was trying to figure out how much time we had left. So in that case, I'm going to go ahead and skip the lab and skip ahead in slides. Oh, I didn't realize the lab goes to two pages. All right. So I'm going to try to wrap some single quote character. All the backslash does is quote the next character. This is how we can turn that dot operator back into a period. I can do a single quote in front of the dot, and that says, hey, this next thing isn't a special character. It's just a period. The next page has the example. So here I'm saying search for backslash dot HTML, and now I only find things that actually have a period in there before the HTML. So collections are a way of saying look for any one of these characters, and you can go through and read to see what we're going, what they are. But here I'm saying look for any vowels. So any single vowel will match. A, E, I, O, U. And the square brackets say that choose one of these. Examples. And character classes. This was one I wanted to get into. Just if I can have the last couple, but go a little bit over here. So character classes are a way of matching multiple things by name. So alpha is all of the letters of the alphabet. And I can use those. When I use those, I have to use them in collections, which means I have to have at least 2 sets of square brackets. We'll get to the next page. Because I need to put the character class inside a collection when I do the search. So here, the first example I've got there is a open square bracket, colon, lower, colon, close square bracket, close square bracket. The outer square brackets are saying this is a collection, match one or any one of these things, not one or more, any one of these things. And then the inner square brackets with the colons and the keyword are saying those things happen to be the lowercase characters of the alphabet you're using right now. Right? Now I can combine these inside of a collection. The second example, I have the capital letter Z and lower. So I'm saying match any lowercase characters or a Z. But again, I'm matching one thing. And I can do multiple character classes inside. They all need their own square brackets and so forth. And I can combine this then with plus and star to say now I want to match more than one, right? So I can say character collection with whatever's in there plus, and I'm saying match one or more of the things that are in this collection, whatever it is that's in the collection. And I have some slides on watching for specific things. Ranges are similar to collections. You can see that on your own. Back references, if you have questions on this, let me know. This is a way of matching something and using it again later on. And branching is in with that. And at this point we're over. I'm sorry. Sorry for all the delays and slow piece. I usually get this done in 90 minutes, and it went a little long today. Sorry about that.
Thank you, Hans, for presenting this useful and important information. If there's anything you want to plug or give your personal information so that the users can contact you through other channels, please go ahead. Yes,
thank you for reminding that. I said contact me, and I should bring back up the page where everybody can find me. It's taking some time to go back. It's also in the PDF you were able to download. Oops, back. There we go. And I'll be in and out today because I've got stuff going on. But while I'm here, I will also be in IRC, and you can contact me there, or you can contact me via Mastodon. And I'm in the LibrePlanet channel this weekend, of course.